Okay, if you looked at my video for number 13, you saw that I was using a strategy called plug points into equations. And it's one of my favorite strategies because it works on all sorts of questions. That one was about quadratic equations. This is about linear inequalities. Something completely different. Yet, we're going to use the exact same strategy because we have equations, obviously, but we also have points. The graphs show us different points. So here's how this works with this one. Is I'm going to pick an easy point, and I'm going to see how it works in the equations. So pick the point 0, 0. That's the easiest place to start. So let's do it right here. If I pick 0, 0, I want to put that point into both of these inequalities. So if we put it in the first one, we'd have 0 is greater than or equal to 0 plus 2. So 0 is greater than or equal to 2. Well, 0 is not greater than or equal to 2. So what this tells me is that any choice that includes 0, 0 in its shading is wrong, right? Because it shouldn't include it, because it gives a bad result. So this is one thing that with inequalities is a little difficult to wrap your head around, is sometimes we plug things in, we don't want them to work. What this has showed us is that choice A is not correct because it's including the point 0, 0 in the shading, in the solution set. But we shouldn't include it because it shows us with the algebra that it doesn't work. So we're going to need to just kind of try other points. And notice the only thing that's different among all these choices is the shading, not the lines. The lines are all the same. So we don't even have to worry about how these lines look when they're graphed. We just need to know what points are included in the solutions. So let's try another point. What's easy here? How about this? 2, 2. I like picking points with the same x and y because I'm afraid if I accidentally plug the x in for the y or the y in for the x, well, I might make a careless mistake. But I'm going to choose the point 2, 2, so I don't even have to worry about that. So in this case, we'll use the first equation again. 2 is greater than or equal to 2 plus 2. So 2 is greater than or equal to 4. Well, it's not. So 2, 2. This point right here, not included, so we can get rid of choice D. All right, let's try something else. What else looks good here? How about, let's do something easy here. Let's do choice C, and we'll do this point. That would be 0, 3. If it helps you to write it down, write it down. So let's do 0, 3. And it's also lazy because I've got a 0, so at least there's that. So 3 is greater than or equal to 0 plus 2. 3 is greater than or equal to 2. Check. That works. So that could be included. Now I got to check it in the other piece here because it might be the case that it doesn't work in the other one. And so that's what a solution set is, right? It's a point that's going to fit into both of the inequalities. So I need to check them both before I get carried away. So let's look at the second equation, which is 2 times 0 plus 3 times 3 is less than or equal to 6. So 2 times 0 is 0, 3 times 3 is 9. So 9 is less than or equal to 6. No, it is not. So even though that point worked in the first inequality, it does not work in the second, so it should not be shaded. So that gets rid of C. And just like that, I don't even need to test anything. It has to be B. That's the only thing that's left. So we're doing a little bit of guess and check here, but I think it's more important to see it as a plug points into equations question. Now look, if you're really good at understanding inequalities, you might have just been able to look at this and kind of know what's going on. But we're getting near the end of the section. We're looking at some hard questions. I'm afraid I might get tricked. And it doesn't take me long to plug these points in. So I think it's worth the time. And then I'm sure that I've got these 10 points. These are all important skills. And you have to kind of know where you might get tricked by something. So as much as possible, it's better when you have a hard question to prove your answer correct. That's exactly what we just did.